Hello, everyone, and welcome to this week's Puzzle of the Week. This week, I'm very happy to get to showcase for you a puzzle by Math Pesto, which is in a series of Math Pesto puzzles, all of which I've greatly enjoyed, featuring this sort of Suguru deconstruction feature, where the solver has to take a gigantic grid and break it into regions of cells, which have size somewhere between 1 and 9, each of which will have in it the digits from 1 up to whatever the size is. I've done a number of these on my stream. They've all been great, but this one is a tribute to a puzzle that is one of my favorites of all time, namely the puzzle Everything is Wroggen by Demano, where there are clues, but every clue is wrong. So in this puzzle, there are German whispers, except that every pair of digits have to differ by less than 5. There are Kropke dots, but digits on Kropke dots have not to be consecutive. There are V's, but digits on V's have to not sum to 5. And this is just a ton of fun to deal with as a solver. It's really fun to watch through and see all of the different ways that these things are placed so that exactly the piece of information you need is that this cell is not next to this one, or whatever other thing there is. Anyway, I think this is a great fun puzzle. I encourage you to try it. I encourage you to watch the solve. And I hope to see you around my stream. Just a reminder, if you've not seen me stream before, you can watch me do these live every week. I stream on Wednesdays and Saturdays, so please feel free to subscribe so that you can come join. I do appreciate you liking the video, and I'd also like to thank our patrons who help support us doing this every week. If you would like to become a patron yourself, you can do that by going to patreon.com/Zetamath. It costs as little as $1 a month in whatever your local currency is, so feel free, but feel under no obligation. We do this for fun, and I'm so glad to have you all here. Enjoy the video, and I'll see you next week. Welcome back, everyone, to what is sure to be an absolute insane puzzle. This is a beautiful combination of all kinds of insanity. So we're going to carefully go over the rules, and then maybe we will succeed and maybe we won't. I'm not surprised that Naverio also went straight for this one. Because, well, as soon as I saw it, I was like, I'm going to do this, and it's going to take me forever, but it's going to be so cool. Okay, so we have to fill some digits in this grid. I swear this grid is bigger than normal, isn't it? Maybe I'm imagining it. I have to fill some digits, or some cells in the grid with digits, not all of them. And I can't repeat digits 1 through 9 in the row or column. So lots of cells are going to have to be empty because there are a whole bunch of cells. I don't feel like counting them, but there's a bunch. So we'll do that. Okay. Every cell must belong to a region, and regions cannot touch each other orthogonally or diagonally. So, and every region contains the digits 1 through n. So not every region will have 9 cells. It could have, say, this many cells. And so if this was a region, it would need to have the digits 1 through 7 once each. So I can have mini regions, but the mini regions just contain the digits 1 through n, which ends up being very important. Okay. And then, so that's Insanity Part 1, is the Suguru rules. And we've done many Math Pesto Suguru puzzles on the stream, I think. We have not done all of them. There are more. Spoiler, this will not be the last one we do, barring that this is way more traumatic than I think it will be. But then additionally in this one, all of the clues are lies. So we have a bunch of traditional clue types, but all of them are wrong. So normally a V would say these two cells sum to 5. In this case, it says they don't sum to 5. The X says they don't sum to 10. A white dot means that they are not consecutive. Black dot means they don't have a ratio of 1 to 2. These are... Okay, so we have to think about what not whisper means. So not whisper, we have to be specific. the difference between every pair of digits on a whisper is not 5 or greater. So that's actually a little different than the logical negation of a whisper. So it's not just that this is not a valid whisper, it's that every sub-line of it is not a valid whisper line. Which I guess sort of makes sense, because if you think about it, a whisper is really sort of a whole bunch of length 2 things. Like a whisper line is no different than if you had a whole bunch of length 2 whisper lines strung together. Okay. Gray square means odd. Gray circle means even. And what is the deal with the renbon? That's the other one I want to make sure. Digits on a purple line may not repeat and may not form a set of consecutive digits. Okay. So here we again have sort of a partial negation of the renbon. They still can't repeat, but they still can't repeat, but they don't form a consecutive string. And then in cages, I'm guessing they don't repeat, but they don't sum to the right thing. Oh, it doesn't actually say digits in a cage don't repeat. So I guess digits in a cage can repeat. They just can't sum to the total. This is the only cage where that could matter. All right. Now, I think we know that every clued cell is part of something. Where is that rule? Regions can touch diagonally. Sorry, I think I said cannot out of reflex. Regions can touch diagonally, just not orthogonally. And somewhere in here, there's a rule that says everything on a cell is part of a region, but I don't see it. Cells containing any kind of marker, including on an edge, must contain a digit. Okay, there we go. So we know, for example, that we get a pretty big region over here for free. Let's see. Do I want to try marking this? So this is already 5 cells. Oh, this continues. That's already 7 cells. So now that's already 7 cells. And this is all one region. And the reason it's all one region is because regions can't touch each other orthogonally. So now that's 1, 2, 3, 4, 5, 6, 7. So this is now a string of 3. So this has to be nothing. So that's dead. And this is now another region, which connects up like that, say. Likewise, this now can't connect. These can't touch each other ever. Let's see. Do I have any other giant? There's a giant pile of cells that are connected up here. I'm gonna make those orange. Let's see. So that's 7 cells, so I can't grow much more than that. There's a large pile above the red region. Let's see. Yeah, okay, so right. Okay, so this is a whole bunch of nonsense. But this whole bunch of nonsense is all connected, so it can't be red. So we'll make it blue. And so now that in particular means that these cells all have to be gray. Gray just means can't be part of a region. Corner can't get out, so it's orange. Could it be part of a 1-cell region, Jay? Okay, so now this blue cell certainly can't join this 27 cage, so these are both not things. This is some new thing. In fact, actually, the yellow also can't. The yellow already has 7, so these are also not part of something. Let's see. If the red wants to get out at all, it's going to connect these, but I don't think we a priori know that this red isn't a 4-cell region. Let's Let's see. This is a little tiny thing. This is a pretty big chunk of stuff. Could make that purple. I think the purple and I don't use purple next to blue because I know it's hard to see, but I think I can use purple and blue far apart without it being a problem. Let's see. We've got we've got this whole cluster. So that's a region. Oh, and that actually even touches here. Okay, so now that's 9 cells. Perfect. Okay. So everything around that turns gray. Oops. Okay, all of these gray. Because now this region's done. It's got its 9 cells and it is happy about its life. Okay. So we've got something happening over here. So these 3 are part of something. And that something can't be the purple. So this is a 3-cell region. So because this is 3 connected cells, and if I connected it to purple, then that would give purple a total of 10 cells. That's too many. So this is its own thing. And so these are grayed off, which now tells us that this is not a 2, 3. So this cell is a 2 or a 3, and there's a 1 in here in this cluster of cells. Now, this is either this either is a 1-cell region or it's purple. But I don't know. I don't know what. Okay. As being pointed out, I can do something similar over here. We'll make this another green. This collection can't possibly join orange. It would make orange huge. So therefore, that's gray. That's gray. Yeah, so this 1 cell, Tristan says, is not purple. If it was purple, if it is purple, then now all of these are purple, and we get 4, 5, 6, 7, 8, 9 purples. 10, 11, 12, 13 purples. I see the problem now. So this cell is not purple. It's its own region. So we'll go ahead and make it blue and gray it off from the rest of the world. So that's actually huge. So that's a 1, that's a 3, that's a 1, and that's a 2. We immediately get. This is a 2, a 4, or a 5. Now, it can't be 6 or higher, or the whisper would be correct. Okay, there's a cluster over here that I have not seen. Oh, this cluster is a lot bigger than I was thinking. Okay, all of this is connected, and it's way too big to be green. In fact, this is its own region. This is 9 cells. So we'll go ahead and we'll give it its gray border. So now I should probably also give that giant region that we said couldn't join purple, I should probably give it a color too. Let's see. We'll give it the color red. Now it cannot join purple, so these are all gray. Let's see, can this join purple? Purple is at 6, so this can't join purple either. This is some other separate region. I'll go back to yellow, I suppose. Actually, no, we'll make this green because it's a little itty-bitty region. So this can't join purple. So purple's actually done. Ah, yes. This certainly can't join blue. Good point. So those are gray. Uh, so let's see. So that's 5, 6, 7, 8. Interesting. Okay, so this I don't know exactly what's going on to happen, or what's going to happen with that. Okay, but red is currently right. This cell can't be red because in order for this cell to be red, I would need for red to have 10 cells because red's currently at 8. So that means this cell's gray. Just by virtue of that. Let's see. Likewise, this cell can't be red either, because in order for this cell to be red, it would need to get 2 additional cells, and it can't. So that's gray. So now this cell, because it's not odd, it has to get out, and so it becomes green along with all of this. That's really cute. I really like that. So because of the O, this cell's even. It's 2, 4, 6, or 8. And so it needs to grow. It needs to grow out because you can only have a 1 in a 1-cell region. And so we've got this whole shape taking place. Now red certainly can't connect here because this red, now if it connected here, would have a bajillion digits. So that's gray. So this region really is 1, 2, 3, 4. So let's think about that. Can I... oops, not that cell. Can I say anything about this? Yeah, it seems like this should be forced, right? So this can't be... Let's see, if there's a 2 on this, then there's a 4 on it. Maybe it's not quite as forced as I would think. I don't know. I'll come back to it. But the fact that all of these are low... I think the thing to notice is that all of these are low, and I've got this fake whisper line here, so all of these are high, maybe? I'll figure it out. I do believe this is super restricted, but I don't know that it's restricted enough that we can just exhaust over it. I originally assumed we could, but I'm not sure. Oh, hey, JC Godar. It was your phone pad puzzle we really enjoyed last time, right? I think so. Yeah, this cell can't be 2. I agree, because 2 connects to both 1 and 4 over here, so this would have to be a 3. And then connects to 1 and 3 over here. Wait, couldn't it go 4, 2, 3, 1? Wouldn't that be fine? 4, 2, 3, 1? I think that might be okay. This cell's definitely gray. Because I certainly can't join these 2. That would be insanity. Let's see. Ooh, you got a CTC feature. Did you get a CTC feature of the puzzle I just did, Tallcat? Congratulations, though, Tallcat. That's awesome. Whether it is the puzzle I just did or not. Okay, this string of nonsenses can't join green, so this is a new string of nonsenses. I don't think I've done critical mass yet, have I? So now this is a wall of gray. Oh, I did. Which one was it? The Renbon between line. Oh, okay. I have a hazy recollection of this. Really, rather than adding new things to the bucket, I should just, whenever I do a puzzle, put it back in the bucket, because by like 2 weeks later, I'll have forgotten everything and I can just do it again. So if it's like a good puzzle, I should just put it back in and just cycle it through and do it again. That is what I'm learning. Okay, so this whole string up here, row 7 has 9 clues. Okay, so I have to count 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So yeah, so all of these cells in this row have to have numbers on them. And so because all of these have to have numbers on them, everything else can't because there are only 9 numbers. So these are all gray, which is sweet. Ooh, are you at your 10th feature now, Tallcat? Oh, let's see. Column 11, the same thing is true. Let's count over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sven, can you put in a feature that when someone in chat says a row or column number, it highlights it or it like labels them in so that I can do that? Congrats. Number 10. That's a very special one. 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yep. So this column, sure enough, has all of its stuff in it. So all of that is verboten. And now that's very interesting because it now means that this is 1, 2, 3, 4. And so now we get to again play the be very careful what is going on here. You did get that really awesome one, Sam, that I was super happy to see the fiveless Shikaku on Simon. That was great. Okay, so these can't have a ratio of 1 to 2 and can't sum to 6. So they extra. I mean, the summing to 6 is pointless, isn't it? Because they couldn't be 2, 4 anyway, and they could never be 1, 5. Uh, uh, but yeah, this can't be 2. This can't have a 2 on it because if this did have a 2 on it, this is Garian's point. The 6 cage is 3 cells. Oh, sorry, I did not read that correctly. The 6 cells, 3 cells. So the fact that that's a 6 cage means this is not a 4. Now, the correct point is that this can't have a 2 in it, because if this has a 2 in it, the only thing 2 goes with on a black dot is a 3 in this screwed up world that we live in, which would make this a 1, 4, but then that would make the V true, so no 2 up here. So one of these two is a 2. So because one of these two is a 2, neither of them is a 3, because it would make the V true. So one of these is a 3, which means that's automatically done. Let's see. So this is a 1 or a 2. Let's see. How big is yellow? Yellow is 3, 4, 5, 6, 7, 8, 9. Interesting. So this digit is either a 2, in which case it could go there. Otherwise, it has to go there. In this yellow region, because it's got to go in the yellow region somewhere, and purple lines can't repeat in this puzzle. Let's see. Okay, so I bet I can do more with this if I am super clever. So I guess the point is these two cells automatically need to sum to 5, because if these two cells don't sum to 5, then I have made a mistake. And so these two cells also need to sum to 5. So because these two cells need to sum to 5, they're either 1 and 4 or 2 and 3. This could never be a 1. Yeah, this can never be a 1, because if it was a 1, I would have to put a 4 next to it somewhere, and that's bad. So yeah, so these two are a pair that sum to 5, and then these two are a pair that sum to 5. Let's see. Yep, these are odd, so I can fill out that these are 1, 3, 5, 7, 9, just for the record. See, now technically this could be orange. Orange could do that. That would be fine. Interesting. Okay. All right. Do I want to now start highlighting this thing? I don't know yet. It's very interesting. So the 1 and the 3 in yellow are up here somewhere. So I guess maybe that's the point. Should I do this? The 1 in yellow is in one of these cells? But sadly, that one doesn't see this cell. Bottom left purple. Bottom left purple is an interesting place to think. Okay, so is there 1, 2, 3, 4, 5, 6? I can't have a 1 and a 6 here. Oh, well, I know none of these are 3. How about that? Let's start with that. I can't have a 1 or a 2 over here. Okay, yes. I think this was actually a very good idea because there was Sudoku to do, and I didn't realize there was going to be Sudoku to do. Okay, so I need a 1 and a 2 over here somewhere. It would make a lot of sense to put the 1 and the 2 there, I feel like. Let's see. Oh, the 18 is everything. Sorry, I don't know why. Somehow this time I also thought the 18 cage was just these 3 cells. But the 18 cage is these. Okay. So because the 18 cage has 4 things in it, I cannot put a 1, 2 over here. So that means this cell's definitely a 1 or a 2, because I need to have a 1 or a 2 here somewhere. So this is a 1 or a 2 and a 4, 5, or 6. Okay. Let's see. I don't think this can be 4 or 5, right? 4 is adjacent to 2 of the other digits that it could be. 5 is adjacent to 2 of the other digits that it could be. So if this is 4 or 5, it automatically... Oh, no, there's not a white dot in each direction. Why can I not read the grid in this puzzle? It's terrible. Let's see. So there's some very clever use of counting to identify how many regions there could be, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 rows and 15 columns, which means that there's at most 15 ones in the completed grid, which means there's at most 15 regions in the completed grid. This all, by the way, owed to, I think it was J40 who figured this out. Of note, by the way, there's definitely a 1 here just by Sudoku on this V. We'll get to that later. So now how many regions do we currently have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 14, because this is part of a region and it's not part of one of the regions that we currently have. So we now also, so if I color this, so let me go ahead and color this. We'll color it orange. No, green. I already have a green over there. I would also request, Sven, a feature where it automatically picks the most aesthetically pleasing color for each part. Perhaps if it figured out the solution first, so it knew what the coloring was going to be, so it'd help you choose colors that would continue to look good as you solved the puzzle, that would be great. Okay, but I think the point is now there are 14, and the thing people are pointing out that is really nice is we know there needs to be a 1 cage in one of these. These can't both be orange. And so our 15th cage is going to be up here, is the point. I mean, alternatively, you don't even have to look at that at all. You could just notice that either there's an extra cage up here that has the 1 in it, or there's no 1s in this row. So in any event, so that's a total of 1 cage from up there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's all the regions. And so because that's all the regions, we need to figure out how to make all of this stuff play nicely with regions that already exist. And so, for example, this is definitely going to have to be purple, joining it there somewhere, which will make purple exactly 9 in size, which means this stuff is going to have to be green, which is going to make green some amount in size. It's going to be gray. And just to reiterate the logic of this, yes, this now has to be yellow because nothing else is getting to it, which now means, let's see, yellow is 1, 2, 3, 4, 5, 6, 7, 8. So yellow needs to finish in 1 cell, so yellow does that. So we're going to gray all around there. Yeah, that's a very clever deduction. Just to repeat it for people, in the rules of the puzzle, there's only at most 1 1 in every row and column, and there's a 1 in every region, and so there's at most 15 regions. We identified that we had 15 regions, and so then we had to sort of bend over backwards to make sure that our regions actually filled all of the requirements that they were supposed to, which is very cool. Okay, so this region's done. Yeah, one of these is a 1 cell region, so one of these is a 1. I don't think that's going to help a whole lot, but it's true. This has to be gray. This has to be gray, which means that has to be purple, which means now we can gray in all of that. Now that's certainly gray. Yeah, now all of up here is certainly gray. Boop. No new regions going up there. Purple's now done, so these are gray. Actually, one of these two has to be orange, and that's going to require 2 orange. That's going to require 2 orange cells. So this cell is gray. Let's see. No region can possibly get to here. Green here only has 1 more cell. So one of those can be green. But then once I get past that line into anything over here, all of this is going to be none thing. This can't be anything anymore. Let's see, green is at 5, 6, 7 cells. So yeah, so that either of these could be green and that could be blue. Okay. Red is at 1, 2, 3, 4. Yeah, red's at 8, so red could take that or that. Okay. So I think this is the state of our coloring at the moment. There's a 1 in a cage in green region in the middle. There's a 1 in a cage in a green region in the middle. We're talking about this one? Right. Okay. So no 1 here. Got it. Okay. So, right. I had pencil marked there had to be a 1 in one of these 2 cells, but this one is a 1 cage, so it can't go there. So that's a 1. So that's actually a digit. Thank you, JC. Yeah, so this is 2, 4, or 5. So now Where does the 1 go in red? 1 in red now has to go over here somewhere. Let's pencil mark. Oh, no, we don't. We don't know that. Red's not done. So let's not be too hasty. Oh, interesting. Where is green going to get its 1? Because there's a 1. Green has to grow into this column in order to possibly get a 1. So we already have a 1 in column 1. We have a 1 in purple in column 2. We have a 1 here, a 1 here. So green can only get its 1 here, or here potentially, but I think that's too far. 2, 3, 4, 5, 6, 7. Yeah, 8, 9. These two are green. That's the green 1. And now red gets chased, because now red is at 8 cells and needs to get a 1 and can't get 1 except from this column. So that cell becomes red, and that cell becomes a 1. So this is not a 1. So now this green region needs to get a 1 either. Oh, it can't get a 1 here. Now this green region needs a 1, and it can only take it here, which finishes this green region. That 1 comes up and gives us the 2 here. We remember, if we are wise, that this cell needed to sum to 5 with that, so that's a 3. These aren't 3 or 2. They're a 1, 4 pair. Excuse me. Okay. We ask where the 2 goes in this region. It goes none of those places, not on there or there. So one of these 2 is the yellow 2. So in particular, this cell is not 2. Excuse me. I'm looking at where 2 can go in this yellow region. It's not any of those places. It's not there because 2 is even. So one of these 2 is a 2. But it's not here because I know actually that there's a 2 in these cells, because purple has a 2. It's in one of those cells. So the 2 is actually placed there. So this isn't a 2. Let's see, we need a 3 in here. It's not in any of those places. It's not there. Oops. Don't immediately know what to do with that. We needed a 1-cell region up at the top. And as Race Master Dave points out, we know where it is now. This is our 1-cell region. We're going to make it purple, wall it off like that. Now, these 2 need to be orange in order to finish that. And so now the coloring is finished up here at least. This is a 2, 3, 4, or 5. It cannot be higher. Let's see. Only one place for 3 in top left yellow. Let's see. Right. Okay. I had failed to notice this 3. Okay, so 3 is placed in this region. I had done this calculation before, but I had missed this 3. So yeah, so this is a 3. Good spot, J. So now let's look at where 3 is going to go in this yellow region. 3 in this yellow region now goes there. It has no optionality left. So 3 in orange, I guess, has still got a little bit of wiggle room left. Why can't row 2, column 1, 4... row 2, column 1, 4 be a 1? Column 14. So I knew there needed to be 15 regions, which means I need a 1 in every so we knew somehow so in order to make this work, I needed an extra region up here was the point. Orange did not have enough cells left to claim both of these sort of dangly bits off the whispers, which meant that there needed to be a single cell region up here somewhere, and so that needed to be a 1. And so if I made this the 1, then I've lopped off my ability to make a single cell region. That was why dictionary. Okay. Oh, why isn't this a 1? Sorry, that could be a 1. Sorry, never mind. I was just being ridiculous. No, that can absolutely be a 1. I wonder if I screwed that up over here. Oh well, too late now. But I might have screwed that up over here because I might have also assumed that that was that was not a 1. Oops. Oh well. Hopefully I've not broken the puzzle. Okay. I have a 1 looking at a 1, 2, I am told. Let's see. Where is the 1, 2? There we go. That 1 looks at that, making that a 2. So this is not a 2. Oops. Yeah, it is true that sorry, so this is not a 3 because it's not next to that. Yeah, so Ren bonds definitely don't repeat. So this cell can't be a 5 anymore because a 5 would definitely be next to whatever this is. But I think I assumed this cell couldn't be a 1. I guess no. I knew this cell couldn't be a 1 already. So I assumed that because of this whisper, this cell couldn't be a 1, but I actually knew it couldn't be a 1 for better reason. Okay, so these aren't 2. So there is a 1 down here, so they're not 4 down here. And I can't put a 1 and a 6 down here because that would make this whisper true. So this is a 1 and a 5. That's not a 5. That's not a 5. This is a 4 or a 6, so this can't be a 4 or a 6, so it's a 3. Because 4 and 6 would add to 10. So this is not a 3, it's not a 4 either, so it is a 6. So that's a 4. Making that whole thing work itself out. Let's see. 1 in the far yellow region, I am told, is placed. So the 1 in the far yellow region can't be here, can't be there, can't be there, or there, because the 1 in here is actually down here, even though I did not do it. Okay, let's do that first. This is not a 1, so one of these two is a 1, so neither of these is a 2, because of that. So one of these outers is a 2. But in particular, that rules 1 out of there and there, and there and there, and there and there and there, and there because of the 1 cage. So this one is actually placed. Thank you, Barbie. So that one there, it looks over and sees that's a 5 and that's a 1. So let's see, is 1 placed in this yellow region as well? 1 is either here or here, I suppose. No, it's not there anymore. So now 1's here. So yeah, so now the other yellow region gets its 1. So these are not 1. So this is not a 4 for the record, because that would make the Ren bond true. So that's not a 4. These aren't 4. So the 4 in this box is in one of these 3 places. Oh, I guess, sorry, the 4 could be there. Never mind. I wanted to look at this more now, because now I know that the 2's on the outside. So the 2... Yeah, so this is... Yeah, okay. I think this still has a little bit of optionality left to it. So this cell can't be a 2 because it, oh no, it could be. Sorry, this renbon is 6 long, not 7 long. Never mind. But this has to be 2, 3, 4, 5. Those are my options. And it's not 4 because of the column. It's not 5 because of the row. So this is always a 2 or 3. But I do have to avoid making this renbon correct. So I could not, for example, make this a 1, 2, 3 triple. But this is a 2 or a 3. Look up. Oh, yes. If I look up, I will see that there is a 3 already. So that's a 2. So this is not a 3 or a 9 by the renboniness. It's not a 3 for this, but let's see. So it's not a 1, 2, or 3. Could be 4, 5, 6, 7, 8, and it's not a 9. Okay, that's a lot of pencil marks, but I'm marking it just to remind myself I know there is a 9 on here. Let's see. The blue 1, I am being told, is placeable. Yep, it looks like the blue 1 has to go here, even if blue expands. Yeah, even if blue expands, which blue probably does, the blue 1 can only go here. Good spot to Florent. So let's see. Does that place the purple 1? Well, I know the purple 1 is up here somewhere. I don't know where yet. Let's see. The 3, actually. The 3 in purple is also up there. Because I have placed 3s in all of these things. So there's a 3 up here, actually, and the 3 is only in one of those 2 cells. That placed the red 1. Thank you. I had not noticed that. That 1 here places this 1 here. So now, if this was a 4, it would make this a 2, 3 pair. So that's bad. So that's not a 4. If this were a 2, it would make this a 3, 4 pair, and that's bad. So it's not a 2. So this actually is a 3 now. So that's a 4, and that's a 2. By the logic of having to make this break correctly. Break in the good way, not break in the bad way. Right, because of the pencil-marked 2s, I actually know that the 2 also is pushed up here. So this is a 1, 2, 3 triple, and I know that I can't put 2 and 3 on the V, so this is not a 1. This is a 2 or a 3. Oh, and it's not a 2 either, because there's a 2 there. So this just is a 3. So these aren't 3. So they're a 1, 2 pair. I can remove my pencil-marked 3 and my corner-marked 1s. Let's see, this probably isn't a 6 anymore. Let's see, what can this be? This can be a whole lot of things, because there's a whole lot of things that are within 5 of 3. Let's see. What about 3s down here? Yeah, 3 down here is actually placed. Oh, maybe it could go here. No, so the 3 in red. So let's do the 3 in red first. The 3 in red has to be in one of these cells. By the by the confluence of that 3 and that given 1. So one of these is a 3. So I can't sneak a 3 over here. So I think the 3 in green can only go here. So now the yellow needs a 3. And the yellow's 3 is now placed there. That probably would have been the easier way to do this than the way I actually did it, but whatever, we'll call it good. Okay, so now that can't be a 3, that can't be a 3, that can't be a 3. These two aren't 3. See, one of these is a 3. I don't think I know which yet. Let's see, 2 is placed in the top right yellow. Ah, yes, this is not a 2 anymore, owing to that 2. So that is a 2. Let's see. So that's going to put some pressure on 2s up here, but probably not enough to be useful yet. Oh, green and blue now. They can't touch, so that's gray. That's been available for forever, probably. So let's see. So green does need a 2. So the green 2 is actually placed here by assorted Sudokuings. Let's see. What about this 2? Do I know anything about this 2? I don't think I know enough. Let's see. 1 in the top right orange is also 2. Let's see. So the 1 up here is not in any of those places. So the 1 up here is in... the 1 is on this dot, right? That's what I know, is that the 1 is on this dot by various Sudokuology stuff. And so once the 1's on this dot, now the 2 isn't on this dot. So those aren't 2. That's not 2. Those aren't 2. So then the 2 is in one of these 2 places. I don't know which yet. I do agree this is an X-Wing on 1s, although I don't... no, it is a useful X-Wing on 1s. Thank you, Judith. This is a useful X-Wing on 1s. I noticed it and didn't think it did anything, but what it does is to make this a 4, because I have 2 1s already in rows 2 and 3, so I can't have a third 1. So that makes that a 4, and that a 1. So that being a 4 means that's not a 4. This isn't a 2 by Sudoku. Let's see. Okay, I need to place a 5 in here somewhere. I can't put it over here, but I don't think that's super helpful. Oh, I could even place the 5 here. Never mind. Super not helpful. Well, that's not a 6, for whatever it's worth. Excuse me. Sorry. That's not a 1 or a 3. That's not a 3 either because of the row. Thank you, Alima. So these are from 579. I have a very hard time sneezing just once. It's very difficult for me. Okay, so 2 and 3. Beautiful. Okay, so Pesto gives a nice hint to make sure that we don't miss this beautiful thing, which is that I need to put 2 and 3 in red, and they need to go in these 3 cells, but they can't touch each other because of the V's. So in fact, we get a 2-3 hidden pair, which means that's the 2 and that's the 3 because of that 3 by Sudoku. That's gorgeous. So now, let's see. Is it a good time to ask about 3 in green? Yeah, so 3 in green. Ah, yes, 3 in green is now placed here, of all places. Let's see. 3 in orange now is not there, or 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 there. So the 3 in orange is actually placed. The 3 in orange goes here. Okay, so this is a 5, 7, or 9 because it's not even and it's not 1 or 3. I'll go ahead and mark that, I suppose. Let's see. So what are the candidates for this? So it's not 1, 2, 3. Could be 4, 5, 6, 7. Can't be 8 or 9. So this is a 4, 5, 6, or 7. That's an enormous number of options. So actually, one thing I'm noticing is that neither of these cells can be 6. So the 6 is getting slowly pinched into here, although that does not seem super useful. Let's see. Where's the 4 in top right yellow? So those aren't 4. That's not 4. So yeah, so one of these two is 4. Do I know which one it is? Well, I'm going to mark that one of those two is 4, per Barbie's comment. One of these two is 4. Can't go over here because it would make the Renbon right. So that 4 means that this isn't a 4. So now none of those are 4, in fact. That's not 4. So now the 4 in this yellow has to go here. And so now the 4 in this green now has to go here. So now could 4 go below the 3 in yellow? Uh-oh, let's go back. Maybe the 4 could go below the 3. I bet that's right. So yeah, so this cannot. So this could be a 4, I think, based on what we know. All right. Oh, the green is done. Let's see. 6. Yes. Well, if they did tell me, I didn't notice. But yes, green is now 9 cells, so I can gray those. 2 in blue finishes blue. Oh, let's see. Blue needs a 2. It's not coming from any of those places. It's not coming from those places. It can't go there, right? So the 2 in blue actually goes here, which then finishes blue. So now that blue has 9 cells, blue can't grow here. Oh, and red is done. Red is at 9 cells, so that's done. So we will get there. So we've done our regions. Let's see. Four in red. Let's see. These aren't 4. Can't 4 go like literally anywhere? Like any of these places? I think I'm missing something about where 4 can go. Why can 4 not go in a 100 cage? Do I not understand the rules for what a 100 cage means? Let's see. Let's try and find these rules. I don't see anything in the rules other than that the cage doesn't total to this. So I think this cage is literally no information aside from the fact that this cell was shaded at the beginning of the puzzle. There we go. Post sneezing recovery. So let's see. So, uh, the remaining red whisper. Ah, that's a good point. Okay, so this is a buy value because this needs to not be 5 away from 2. So can't be 3, can't be 4, could be 5 or 6, but then can't be 7, 8, or 9. So this is a 5 or a 6. Oh yeah, the the evil. I hope you could not hear the nose blowing. That was the whole point of me changing it off. Um, let's see. Okay, so this will be 5, 6, 7. Tempting. Uh, just some dubstep. Okay, well that's appropriate, I suppose. Uh, yeah, I did not script up nose blowing music in advance. Let's see. So this is can't be 1, 2, 3, 4. Could be 5, 6, 7. This is a 5, 6, or a 7 as well. Would be a good superpower. Where is 2 in the middle green? I'm being asked. So 2's not there. 2's not there. 2's not here. So 2 is here in middle green. Thank you to whoever said that. Thank you to J40 for saying that. So these are now not far enough away from 2. So these are, well, they're not 1. They're not 2. Sorry, this one could be 2. Oh, this one can't be 2 by Sudoku. It can't be 3. Be 4, 5, 6, and then can't be 7 or more. This one can't be 6 because it's clued as not being able to be 6, which gives us a 4, 5 pair, which means this is a 6, which tells us this is not a 6. Now, when I go to look at 6 in purple is not here. It's not here. I guess there's still a little flexibility for where 6 goes in purple. I can fill in these digits. There are 1, 2, 3, 4, 5, 6. There are 7, 8, 9 is what these digits are. This one's not an 8 because that would make the X correct. So this is a 7 or a 9. That means I can fill out the rest of the region. It's 1, 2, 3. These are 4, 5, 6. Now, neither of these can be the 5, because if either of these were 5, the thing would be next to it. So that's a 4, 6 pair, which makes that the 5. So let's go ahead and fill in the rest of these cells. So we've got 1, 2, 3, 4, 5, 6. These are 7, 8, 9. Oops. These are 7, 8, 9. Which is, I think, not currently valuable. We'll frame it in the most optimistic possible way. There's a 4 up here. Thank you, Jay. Welcome back, by the way. 6 and 4. The 4 can't go across from an 8, so the 8 is placed here. Good spot. So, and now 6 is placed in purple, because 6 can't go next to the black dot with the 3. So that's good. 6 in blue now. 6 in blue's got to be in one of these two cells. And it can't be that one. So 6 in blue now is here. If 6 was here, it would make the whisper correct. So that's a 6. Okay, so 6s. see. What about yellow? Yellow's 6 needs to be in one of these two cells. I don't think I know which one. Oh, the dot on the whisper in orange. Okay, so there's a 1 here. It can't be a 1-2, can't be a 1-3 or a 1-5. Yeah, so I think this is now got to be 1-4. I think that's the only option because there's a 3 and a 5 in the column. They can't be more than 6 apart. They can't be next to each other. So this is a 1-4, and so I know the order. Thank you. So that 1 gives us a 2 and a 1. This digit doesn't have a whole lot of options. It can't be a 2, 3, or 4, so it has to be a 5 in order to make that work. So these are a 7-9 pair, which makes this cell an 8, because I need to put an 8 somewhere in here, and I can't put it next to a 7-9. So these two are a 6 and a something else, and a 2. Right? 6 and 2? Yeah, 6 and 2 sounds right. That one's not a 2, so it's a 6 and a 2. 6 can't go next to 7, so that's a 9 and a 7. That's 7. Sees down that that's a 9, and that's a 7. We've done a lot of work on this cell. In fact, actually, we now know where the 9 goes in the column, because the column needs a 9, right? 2, 3, 4, 5, 6, 7, 8. Oh, we don't know that the column needs a 9, but this can't be 4 or 7 or 5 anymore. This is always 6 or 8. Those are our only options. And so this is a 6, 8, or 9, just for the record. Okay. So where do... Oh, let's see. This region is... No, that is 9 cells. Okay, so this does need the full complement of Pokemon. So we do need to get 7, 8, and 9 in here. I don't quite see how that's working yet. Let's see. Row 13, column 6, says Nicholas. Yeah, this is a good thing to write down. So it can only be... Could be 3, could be 4, could be 5, but can't be 6 or higher. So this is a 3, 4, or 5. Let's see. This... I do need a 5 and a 7 in this box that cannot go here. But I don't think that helps immediately. Oh, there's already a 3 in the row, I'm being told. Yes, so there's already a 3 in the row. Good. Which gives us a 4 or 5 pair in the column, which I guess is not immediately helpful, but we can fantasize. So where's the 5 going in this box? The 5 in this box needs to be in one of these two cells, because it can't go next to the 6. Is that helpful? I do not know. I think I kind of want to, as ridiculous as it sounds, write down candidates for these. So these are not 4. These are not 5. Okay, maybe this was more ridiculous than I had hoped. These aren't 3. I don't know. It's defensible. This one's not 3 either. Oh, wait, no, sorry. It could be 3. This one's not 7 or 5. That's the ones it's not. So this is 3, 8, or 9. I'm told Garion has a good point that I will look at in just a second. Okay, so Garion has a good point about 4s in bottom yellow. Good point. Okay, so 4 in bottom yellow is here. Followed by bottom green, where the 4 now has to go here. Good. I think we're back on the path that we misplaced something before, but I think we now are back where we once were. Let's see. 4. So these are not 6 or 8. That 4 is looking at a 4-5 pair. Aha. Aha. Gotcha. Okay. So that's a 5. So these aren't 5 anymore. So they are from 3, 7, 9, and such. So now the 4 is definitely on this dot. So the 8 is definitely not on this dot. The 4 being on that dot means that's not a 4. So the 4 in this box now... Oh, the 4 in this box has 2 places. It's there or there, I believe. Let's see. The 5 looks up. This 5. That looks up and sorts things out. So that's a 4 and that's a 5. Good, good. Okay, so that's all sorted out. So that's not a 5 anymore. It's just a 7 or a 9. Let's see. See, some 5 somewhere looks down at a 5, 6, so that's not a 5 anymore. I think there's another 5 looking at something, maybe, possibly people are telling me. This 5 looks down at that. There we go. That's the one. So that's a 6. So this is not a 6. It's a 5 or a 7. That 6 now looks down and sees that that's a 7. That 7... I guess it just tells us one of these two is a 7. That's not necessarily huge news. The 5 in yellow looks down. So am I supposed to ask which of these two is 5 now? Is there one of these two that obviously can't be 5? That 7 looks up at green. I don't know what we're talking about. 7 in yellow is great. This 7 in yellow? Okay, so let's write in the candidates for this row, I think is what people are wanting me to do. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see. So, oh, right. Okay. So the point is this being a 7. So I said that, but then I did not follow it through to say that that actually places a 5 there. That's what people were observing. Okay. So now this digit is going to be under pressure from this cage because the total of these digits is 24 plus 8 is 32. So I can't let the digit I omitted be a... wait. Doesn't the 27 cage automatically broken? I must have mismathed that. What did I do wrong? Okay, so 8 plus 24 is 32. 32 minus 27 is 5. I don't get it. Let's see. So this 27 cage doesn't do anything, right? This 27 cage is no longer part of the solve. Uh, uh, I'm mostly just worried because I never use this 27. Uh, okay. So 5 in red is placed. 5 in red is placed. I agree. Uh, yeah, so I just whatever way it happened, I didn't ever use the 27 cage. Uh, which is fine. It probably is kind to have a little bit of extra wiggle in a puzzle like this. Uh, I was just briefly concerned because chat was mentioning it, and I didn't think it was even possible to make this sum to 27, which is why I was concerned that something had gone wrong. Let's see. So let's see. Nicholas says, row 8 has a 4 in green placed. 2, 3, 4, 5, 6, 7, 8. Let's see. I need a 4 in green, and it has to go here because of my 4 pencil marks. I agree. This is a 7, 8, or 9. Right? Yes. This is a 7, 8, or 9 to finish the box. Okay. What is left in this region? 3, 4, 5, 6, 7, 8, 9. These aren't 6. That one's not a 5. That one's not a 5. Let's see. So that gives us a 6, 8, 9 triple, if I am reading that right. So that is a 6, 8, 9 triple, which makes this a 5. Bizarre. So that's not a 5. Okay. This is an 8 or a 9, so this can't be 8 or 9, or it would make it right. So that's a 6. So that's not a 6. It is an 8 or a 9, which gives us a 7, 8, 9 triple in the column. So therefore, this is not 7, 8, or 9. So this is neither 1, nor 2, nor 3, nor 4, nor 5. Could be 6, but can't be 7, 8, or 9, so it is a 6. So let's see. 5 in blue looks left, I am being told. Oh, I think that was an older comment. At this point, let's see. So we did a whole bunch of stuff there. Okay, so what are these digits? So these are we've got 1, 2, 3. We need a 4. We've got a 5 and a 6. Then we need a 7, 8, 9. Yes. So this is not 7 or 9. It is 4 or 8. This is just about anything it looks like. Let's see. What else can we do? What are these digits? These digits are 2, 3, 4, 5, 6, 7, 8, 9. Got it. Okay. So it'd be real nice if this was a 4. But I don't think I can force that to be a 4 just yet. They aren't 7. Oh, they're not 7. That's very helpful. Because of the 7 in the column, you see. Thank you, chat. So that's a 4, 8, 9. So that's the 7. And so now the 4 does have to go in the middle because the 8 and the 9 can't play with each other in this particular arrangement. So that's a 4, which places the 4 over here, which means that's not a 4. So this is a 7 or a 9. Let's see. Ah, now if this is a 3, these definitely have an 8 and a 7 or a 9, so this can't be 3 anymore. Thank you, chat. That was a wise observation. So this is an 8-9 pair. So now what can this be? Not 1 or 2 or 3 or 4 or 5 or 6. It could be 7, but can't be 8 or 9, so it is 7. It's the only option. So now what's this cell? It's not 1, 2, 3. No, it's not 4. It's not 5 or 6 or 7 or 8. This cell is a 9, so that's not a 9. Makes that a 6, 8 pair. So 1, 2, 3, 4. This has got to be the 5 for yellow. That 9 looks over and gives us an 8 and a 9. The 8 looks over here and gives us a 6 and an 8. Did I go on a more complicated journey than was strictly necessary in order to obtain that this was a 7? That sounds like a thing I would do. Let's see. 9 in the top yellow. Oh yeah, I have not been keeping up on my pencil marks at all. That 9 looks up and sees that that's a 7. So that's an 8. So that's a 4. So that's a 9. Just updating pencil marks there was a necessity that I had not indulged in a bit. Okay, does anything see this 8 or this 9? I don't believe so. Let's see. 7 in green is in... not in one of those places. So that's a 7. Good spot to Ilm. Welcome back, Ilm. I think I saw you a while ago here, but good to have you back. Let's see. 3, 7, 8, 9. There's a 7 in this column. The 7 in this column now gives us the 5 and the 9 there, which gives us the 8 there, which tells us these aren't 8 or 9. They are a 3, 7 pair, and it's resolved by the 3 there. So that's a 7 and a 3. Let's see. So that 7 and 8 look up and give us a 9 there. That 8 and 9 look over and give us a 7 here. So this is an 8. Gives us a 9 and an 8. And this 8 looks over and gives us a 9 and an 8. And I think that is the whole puzzle. Very nice. That was super fun. And actually, as everyone in chat said, not actually all that difficult given the ridiculousness of the idea of the puzzle. I think it was quite approachable. So is the next one going to be the 2 truths and a lie version of this Math Pesto? Yeah, I really love these, and I don't think Simon has done one of these yet, right? The gas level. I would not go with gas level, but I feel like this is as easy as it is possible for an everything is Roggen puzzle to be. But yeah, I think this is very... I think all the ones in this series that I have done would all make very easy features, which is just why I'm surprised that I don't think any of them have been featured yet, because there's about a dozen of them to choose. Mark did one of them. Okay, awesome. Yeah, I think this would be a very appealing, probably Patreon video, because it involves so many rule sets. But I think this would be a great one to do for Patreon. All right. I'm going to take a short break. I'll be right back, and then there will be more puzzle action, probably Sudoku action.